No, 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 no. We're not doing that bit. We already did that years ago. Let's get into the episode.
I'll be back.
Many years ago, in 2018, I have built an AI-powered Terminator skull. It was powered by the BeagleBone AI, the first dedicated AI single-board computer. It was very limited at the time, but since then, a lot of years have passed, and now we have Raspberry Pi-based AI things like the AI camera and the AI head. And I wonder, what would happen if I put those into the skull? How far have we come? And how terrifying is this time? Ever since the Raspberry Pi AI head or its predecessors came out, I wondered if this really changes a lot with how you can run AI things on single-board computers. It turns out LLMs don't profit from that at all. All the models that you find for these Raspberry Pi AI head and also, of course, for the Raspberry Pi AI camera, they are strictly vision-based. But isn't vision the actual best AI application at the moment? Ones where it's actually practical and not just hallucinating mashed up words that don't really have any meaning or understanding to them. So we're focusing our project again on the vision application, but we're gonna get a lot more sophisticated this time. I was curious if the AI head and the Raspberry Pi camera would do anything for other things besides vision models. Turns out they don't. I tried running Tiny Llama on there, and even that takes pretty much forever, or not forever, but it takes some considerable seconds. So it's not like you can talk to the machine and it answers back in a natural way. So nope, that's not there yet. But the vision models have improved quite a lot. And if we look through the examples, we find various things about detection. And I was wondering, can you actually use both of these? So do you have a benefit in using a Raspberry Pi AI camera and the AI head on one thing? So I put them both in my project. Just because I just want to know. For logical and obvious reasons, of course, I want to make the whole thing not just like an AI camera demonstration. I want to make it as terrifying as possible. So excuse me while I pick up a thing from the future to show you. But the magic of time travel, I can now show you the skull, and I actually managed to put all the stuff that we need right into the head of this thing. And below here, there's only a power supply. So our new capabilities in tech allow us to put enough processing power into the actual head of a thing to make it a functional head that has vision and can recognize things. Okay, now let's get back to how I built this thing, and I have to bring this back or it will be missing for Clem, who records the demo. This time in the programming void, I'm only showing you tiny bits of the code. Why? Because I mostly used the Copilot function of VS Code not to code it necessarily that much, but because it allows me to remotely program on my Raspberry Pi from my main computer. So it's a lot more convenient for me to do it that way. And I can't start the actual code from VS Code because it's dependent on some stuff that can only be started locally on the Raspberry Pi. So I always have to go over to the Pi to actually activate that code. Mainly the Qt preview is, I think, what makes it only properly execute locally. But VS Code's Copilot function was very handy in adapting the original examples to my new use case. So I downloaded all the YOLO models and the YOLO examples for the Raspberry Pi AI Plus head. It has a difficult name, and for the Raspberry Pi AI camera. And I discovered by looking through the codes that you can't really combine those. Those are different models, and very interesting. To actually get a different model to execute on a Raspberry Pi camera, you basically flash to it from the Raspberry Pi. So you can't change models on the fly, which you can do if you use the AI head. They have different functionality, they use different types of models. Right now, I think there are only a few vision models ready-made, but you can train your own. Of course, I don't have the time to train my own model, so I use what I have, but I can compare both versions. And it turns out the performance with the Raspberry Pi AI head is a lot better than with the Raspberry Pi camera. But if you are limited in CPU power, and if you only use, let's say, lighter detection, like presence detection, just want to know if something moved, if a person came in there, or if a specific object moved, then you might be better off with the Raspberry Pi AI camera. Also, it does consume a lot less power, and it doesn't get hot, which the other one does, quite a lot. So cooling is of the greatest necessity. Also, the whole thing consumes quite a lot of power. In my code, I made sure that I will always try to keep the object of interest in frame. What's the object of interest? If it's a human and it's close, then it's a human. If it's a laptop or a keyboard, then it will focus on that. Specifically, the one that it is certain that's the clearest, biggest, the closest object. That's what it will focus on and move the head accordingly. Just with some servos, I made a shield for that. Just by hand soldered up some wires onto a breadboard, not a breadboard, onto some protoboard, and connected that to my Raspberry Pi. You have to replace the original headers that come with the AI head to make that possible, because the original ones are a bit too short for proper connections. Now that everything is assembled, it's more about tuning the code. So I use Copilot's function to alter the way the motion smoothness for the servos work. Turns out I can smooth how much I want. It doesn't really matter, because the whole construction of the skull is so jerky and so janky. It's a compliant mechanism, so if you stick your hand in there, it will just give way and there's no risk of getting pinched. This is actually a safety feature, but it also makes the movement a lot more jerky. But with the AI power, we can now adapt to this jerkiness quite a bit better. So we let it decide if it actually needs to reframe, or if the object is far enough in frame that it just doesn't move at all. And for more visual clarity, not only is there a screen where I can see what the thing sees, but it also tells me what it thinks about it with a NeoPixel ring in its eye. Getting that NeoPixel ring to work on a Raspberry Pi 5 was quite tricky. You can't just use the normal libraries. The Pi 5 works differently with its GPIOs than previous versions. So you have to use a library called Neo5Pi or Pi 5 Neo. I think it's Pi 5 Neo. That uses SPI to communicate with the NeoPixels, which has the added benefit of a faster communication process, but also you can only address one of them, I think. Maybe you can work around that. Let me know if you know how. But turns out now NeoPixels can be directly connected to Raspberry Pi 5, and I use this ring that I embedded into the skull to show me the confidence level of the detection. So if it actually thinks there's a human, it will show the confidence level by green LEDs. The amount of green LEDs is how confident it is. In case it sees a laptop or keyboard, it will use red LEDs to indicate that. And there's also a counting mode where it adds an LED for each object that it recognized correctly. Once I have verified that all the stuff works, I just used some servos glued to a piece of wood to make sure that they all move as they are intended to, but I can't really confirm the directions now. So I had to build the thing and put everything inside this little guy here. The bottom is just power supply, nothing else. We have two switches for system power and a second one for motor power. So I can quickly turn it off in case it tries to destroy itself. All these mechanisms are compliant, so in case I go in there with a finger, it won't pinch my finger or hurt me in any way. Yeah, so let's give this thing a try. In my first few tests, you can see I had to reverse the direction of the servos, which was quite easy by just putting them negative instead of positive. So the camera would actually follow me. I really like how it decides itself what is the object of interest and what to follow. So if you're basically getting closer and stuff, it will switch to you. This is something that the old camera did not pick up. And something that I noticed in the examples is that there is basically no object profiling anymore, or like person profiling. Before you had examples where they would detect facial expressions, age, gender, race or whatever, like personal data. And now there are no examples like that. It just just detects specific objects and humans and poses, but nothing with personalized data. I think that is one of the things that they took care of with complying to privacy regulations. And I also think like the way it's now done, that's a lot more practical, like for stuff that you actually want to build. I don't care how old I look, I know that I look old. So what does the code actually do in there? Well, it detects if there is something, it locates where it is and draws a bounding box. Then it will find the center of that box, and then it will basically try to keep that in the center of the frame, mostly. There is quite a wiggle room where it can decide itself if it wants to reframe, to keep it in there. And if there's nothing, then it will just center back and just wait for something to happen. And if an object enters the frame from one side, it will quickly look at that position. So it's quite terrifying when you're going to a room and you forgot that it's already running, and then it's like all of a sudden moves and looks at you. Yeah, it's quite terrifying. I'm specifically curious how good this thing tracks me and my reaction to it, because it's quite astounding how lifelike AI-driven things get. Like the Turing test actually tests how far you are into being deceived by a computer that is actually living. And if that thing moves and sees you and stuff, yeah. As it is, it's basically a great demonstration on what AI vision can do now on very budget-friendly hardware in comparison to what AI stuff usually runs on, and how small it all can be. So you can integrate that actually into everyday things. So pretty much anything could look at you all the time and collect data about you and analyze your behavior. And maybe that wasn't the best idea to build that. I hope this gets you to try out some AI vision things. Maybe you have a great project idea for that. If you want to download the code and stuff, it's all for free on the Element 14 community as always. You can also go there to connect with me and all the other hosts, ask your questions, or show me what you have built. And now I need to make some corrections. But then another project is waiting for me.